Alright guys, so I'm just going to go through chain rule once more because I know it's like the bread and butter of the topic, what you're going to be doing. So make sure you really understand chain rule here with transcendental functions. So let's have a look. You got to remember the rule here for logarithmic function, okay? The only thing we know, remember the only thing we know is the derivative of log e of x, not 2x, not negative x, not 3x, just x. Okay, just x by itself. We know the derivative of this is equal to 1 over x. That's what we know. This is a, like a one rule that we know. That's all I'm asking you to memorize for now. Later on, I'll teach you where it comes from, but that's what we know. Okay, so right here, the problem here is we have 2x. That's something we don't know. We know if it's 2x. We know if it's x, but not 2x. So how do I do this? Well, because this is something I don't know, what I want to do is I want to make it something I know. So I want to say let u equal to 2x. Because if I do that, what I'm now going to get is I'm going to get a new function where it's y is equal to log e of u, which I actually know dy du, which is the derivative of this, will actually be 1u, based on the rule. Okay, all I've done is change the letters. So, from that idea, I can then say, okay, well, I've got dy du, but at the same time, remember, I let u equal to 2x, so I got to find out du dx as well using chain rule, which is actually 2. So if you multiply these two together, okay, because remember dy dx is actually equal to dy du times du dx, which conveniently I've got du dx here, which is the derivative of u in terms of x, and I've also got dy du. Okay, so multiplying these two together, this is what I'm going to get. I'm going to get, okay, well that's 1 on u times du dx, which is 2, but u was actually 2x. So that's times 2, and conveniently I can say these two cancel out, and I've now got 1 on x. Okay? I think this screen might have just cut it off, but just in case, yeah, it cut it off. There you go. Okay, so it's actually equal to 1 on x. What happened there? Okay, so that's how you do that problem. Now, it won't be that different even if I move on to this problem, for example. Okay, remember the rule for this problem again, the only thing we know is this. We know that if y was equal to sine of x, we know the derivative is actually equal to cos of x. That's all we know. We don't know anything else that's not x, which in this case is 3x. So what I'm going to do is I'm going to do exactly the same thing. I'm going to say, well, let u equal to 3x. Because if I do that, if I let u equal to 3x, then what I'm going to get now is I'm going to get, okay, well, u equals 3x. My new equation is y is equal to sine of u, which I know the derivative dy du will have to be cos of u, because that is what this rule is. It's saying when you have one variable, sine of x, it's cos of x. So if it's sine of u, it's cos of u. The next part is, okay, well I found dy du, but I also need to find out du dx. Since I know u equals 3x, then the derivative du dx is actually equal to 3. So following on, that means that the derivative, okay, the derivative dy dx, which is according to the chain rule, is dy du times du dx. That's just a simple, multiplication of these two functions here, which I'm just multiplying cos of u and 3, because that's what my dy du is. dy du and du dx. Okay, so putting it all together, that's cos of u multiplied to 3, and that gives me 3 cos u, which the answer is, remember u is a made up variable, so my answer is actually 3 cos of, and u, which I said before, which is 3x, so that's 3 cos 3x. And that's just using the chain rule, okay? Just revision of what we did in term 2. Alright? So there you go. That's the same old problem for each one. Replay the video, just get the idea of what I'm doing there. The rules are there. We're just trying to make the problem a bit more simple to understand by letting it be another variable. In this case, we let it equal to u. Okay? There you go. Hopefully that explains the chain rule a bit better or reminds you of how to do it again. Okay?